In the previous class, we had obtained this result that in the thermal state, since the overlap between Nk and Nk plus 1 or Nk minus 1 supposed to be 0, therefore the expectation value of the field itself, which is made up of objects like this in the full expansion, becomes identically 0. So therefore, thermal states also shares the same property as far as the expectation value is concerned with the vacuum state. Unlike the coherent state where the field expectation was non-zero for coherent state, for vacuum state this was zero. For thermal state also it turns out to be zero. But now let us check, compared to the thermal state, compared to the vacuum state, what is the structure of correlations in the thermal state. We remember that the correlation structure in the vacuum state was something 1 minus 1 upon 4 pi square divided by the invariant distance d square or something. For coherent state, there were extra terms which were like classical location x expectation times location y expectation. Let us try to find out whether, since expectation of phi and expectation of phi y at location x and y are identically 0 for the vacuum for the thermal state, whether such a result is true for thermal state as well, that I do get total correlation in the thermal state as vacuum part plus an extra term which is individually expectation product. And if that happens, then the correlation function will share the 2-point function will of the thermal state will share the same value as compared to the vacuum 2-point correlation as well, because individual expectation happens to be 0. So first we need to check, do we have a structure like this which was true for coherent state or not. In order to obtain that, again we have to do the same computation, that I have to now put two operators alongside with the density matrix in the trace, divide it by z beta, and therefore that would be the definition of phi x phi y expectation value, the 2-point correlation function. All like before, I have to write it in the proper basis. So I will squeeze the operators appearing in set nk and set nk bra and ket, sum over all the possible nk's set which is appearing over there, and divide it with z beta. Z beta, we know what it is. This piece we have already computed so many times, and now we have to find out what is this. Okay, so the same trick I will play. First I will compute the expectation, the operation of two phi's on the nk, set nk, and take the dagger of that to convert things into like this. However, this time I have to be careful. When I do the dagger of this thing, the operator's order flips. So I have a phi x, phi y. Then if I take the dagger, I would get a nk, ket will become nk bra, and phi 1 operator and phi 2 operators, the product's dagger will appear, which will be equal to phi 2 dagger, phi 1 dagger. So it would become phi 2 dagger, phi 1 dagger, and since they are Hermitian operators, real scalar field, the dagger is equal to themselves, so I will get a phi 2 phi 1. When I do the dagger, the operator order flips, phi 1 phi 2, dagger will become phi 2 phi 1. So therefore I should obtain first the operation of phi y phi x, take the dagger of the whole thing, then phi x will come on the left, phi y will come on the right, and the ket will become a bra. But up to that here, the straightforward algebra is fine. We have already a result of how phi x acts upon nk in the previous discussion session. We'll realize that it is plane wave times root nk with one particle down in kth basis, and which kth basis is that will be summed over. Similarly, the second term comes with a plane with a minus sign in the exponential. Kth mode has one extra particle excitation, and the normalization corresponding to a dagger's action is nk plus 1. So one extra particle in mode k, and that mode will be changing as we sum over the integration. So that is the operation of the first phi x on nk. Now I should do the second phi y operation to that. So I will write down phi y also in the similar kind of expansion basis that we have seen before, and only here I have to put that this is being done at location y. So everywhere with k primed, exponential will be made up of function of y, and that is going to hit the phi x nk, which already I have a result for this as the whole summation over here. Okay, So these two operators will hit these two states sum. So there are effectively four types of terms going to appear. This AK hits this whole term. Remember, this whole term is nothing but AK acting on the set NK. So this AK primed will hit AK NK, or this AK primed can hit this state. Remember again, this whole state is AK dagger hitting the set NK. So the possibility is AK combines with this AK, or this AK primed combines with this AK dagger, or that AK prime dagger combines with this AK, or that AK prime dagger combines with this AK dagger. So there are four possible sets of operation, and every time these pair of operators are supposed to hit this NK set. Okay, so that is what the structure is. So what will happen if this AK primed goes ahead and hits this NK, NK minus 1 and NKN and whatnot. So this AK prime is supposed to bring down number of particle by 1 unit. In which mode? K prime mode. And later on all the K prime will be summed over, meaning one by one it will suppress particle content in each mode by 1. Not simultaneously in all of them, but it would be summation over first. The first state will have one particle, K1 will be going down and all other things will be like before. In between there is a NK minus 1. Then the second term would be NK1 remains the same. The second state gets a one particle reduction, and NK minus 1 is already there, and so on. So this AK prime will one by one gradually shift down the number contained in each mode one by one as a summation that is equivalent to integration by 1 unit down. So therefore, the AK primed will keep making things one by one down. So it will either create K primed. If K primed is equal to K, then this NK minus 1 state will go down further by 1 unit. It will become NK minus 2. Or otherwise, when K primed is not equal to K, then the other K primed mode, which was initially NK primed, will go down with 1 unit. So it can convert the state which it is hitting, the AK primed, which is appearing over here, is supposed to hit this state. So there are two possibilities can generate: a state of this kind, after action on this, state of this kind or a state of that kind. This is for K prime is equal to K, and this is for K prime not equal to K. The same logic is there when the same logic is there when the AK primed dagger, let me make it clean again so that we can see with clarity, that AK prime dagger goes and hits this one, so, or that one. So first we will consider its action on this one. So if AK primed dagger goes and hits the second ket, which has an NK plus 1 particle, if K primed is equal to K, it will increase the particle content in kth mode by 1 more, so it will become NK plus 2. Or if K primed is not equal to K, so somewhere else it will increase the particle content with 1 unit. Okay. So again, the action of AK primed will either raise it by 2 or it make it something like that. AK's primed action on the first ket was either break it down by 2 or somewhere 2 particles, one each is missing. So action of this converts it into minus 2 particle in K mode, or minus 1 and minus 1 in K and K prime mode. Similarly, action of this object on this converts either plus 2 in K mode or plus 1 in K and K prime mode. However, action of these things results in states like this, but these are meaningless states in the sense that when I take the overlap of the e to the power minus beta h nk, remember when we are doing this, we are computing phi y phi x. Ultimately, the whole thing at the end of the day, the dagger of that has to be taken and overlap with e to the power minus beta h nk has to be done. So if the whole thing we do, then e to the power minus beta h nk is the eigenstate equation. Ket nk is eigenstate of e to the power minus beta hk. So I will have an overlap of these kind of states with Nk. And we have seen before, if Nk particle content in Nk does not match from the particle content of the number of particles from in the bra, the overlap is 0. So whatever overlap action of this does onto this, its action of this does onto this state, its overlap with e to the power minus beta h times this will be 0. Similarly, whatever action this does on the second kit, its overlap with e to the power minus beta h n k would also be 0. So only thing which will survive under this action is when this AK goes and hits on this, and when AK dagger from this side goes and hits the first kit. So if you do that, if AK goes and hits the second term NK plus 1, so this is already one particle extra, K will search for this thing and find out if it is the same, it will bring down it to be NK back, so it will become similar to NK again. Then the overlap will survive. Similarly, when AK dagger and goes on and hits the NK minus 1, the first kit. Remember, both the operators were supposed to act on both the kits appearing in the expansion. So when this term goes and hits this one, then already it was NK minus 1 to begin with. AK dagger's action will make it one particle extra in NK minus NK, the kth mode, it will become back to NK. So you see, out of the 4 possibilities we listed down above, let me again for one more time clean it up. There are 4 possibilities when AK over here hits this state, or AK primed over here hits this state, or other possibilities that AK prime dagger hits this state, or AK prime dagger hits this state. Out of these 4 possibilities, 2 possibilities create a state different than NK. So state different than kit NK will under overlap with e to the power minus beta h Nk coming from the right hand side will vanish. So 2 states of the 4 possibilities will vanish. Only 2 states will generate again the state Nk back, and these are these operations when AK acts on Nk plus 1 state and AK dagger acts on Nk minus 1 state. So you do that. You write down what survives. So ultimately, as repeatedly we are discussing, action of this onto this state and action of this onto this state survives. You can see now this was already AK and AK dagger has to act on this. So I will have a structure like AK prime dagger AK or AK primed AK dagger. This state is AK dagger kit NK. So ultimately what is going to survive is the plane waves coming from both sides. So you see surviving terms plane waves. This should combine with, this should combine with that, and this should combine with this. So if that happens, you can be slightly attentive. The first AK primed AK dagger will come with this plane wave combination, and the second term where the AK dagger primed comes with AK will come with this plane wave combination. That you can verify from here. That you can verify from the combination which is going and hitting the state. Okay, so let me clean it up and you can see what we have written. 4 possibilities, 2 of them are different states than kit NK, 2 of them are same states as NK, and only those 2 states will survive the overlap with e to the power minus beta hk and e to the power minus beta h acting on NK. So ultimately the inner product which is going to survive is things like this. Okay. Again, for this to survive exactly, the K prime should be equal to K. Otherwise, this will create an extra particle in NK mode and this will decrease somewhere else. So they should compensate each other's action. Similarly here, the dagger and this thing should not decrease and increase in separate modes. Otherwise, number contents will change. So they should do the operations in the same mode. So therefore, there should be a delta K minus K prime. That can be verified from the algebra itself, that the commutator structure, if you implement to write it down neatly, you will get that the K and K prime have to be the same. Okay, so we have the expectation of operators which will appear in the whole computation of the expectation of phi x phi y e to the power minus beta h, where this became e to the power minus beta omega k n k and the kit nk. So overall, what we have to get is the squeezing of phi x phi y between nk kits. So that is what we have done over here. You can see ultimately it is the surviving part of phi x phi y in the states kit nks from both sides, and this is giving me this result. So ultimately this is what will go and sit in this expression which we wrote down over here. We needed to write the expectation of the whole thing in the numerator. Out of this trivially converted itself into e to the power minus beta h beta summation or integration d3k n k omega k, a real number, and then the set nk back. So this can go out of this whole thing here, and ultimately phi x phi y will get squeezed between nks. And out of this, as we discussed in the preceding few minutes, that only two terms will survive, and these two terms are exactly this: nk plus 1 with plane wave structure like y minus x, and nk with plane wave structure like that. So you go over here, you go into this and compute. So just a second, I have to, yeah. So I had to take the dagger of this thing first. So I had to take the whole thing's result here, dagger of this thing first, and then take the inner product with respect to this. Remember, we wanted phi x phi y over here. What we have obtained over here is, in this case, is phi y phi x. Remember, phi y is appearing over here and phi x is appearing over here. So what we have to do, we have to take the conjugate of this. The conjugate of this will flip the minuses here and plus over here. So ultimately, in the interesting result, a minus should appear here and plus should appear here. So therefore, in the computation of the expectation of phi x, phi y, a minus will appear here and a plus will appear here. So there was an error in typo which I had forgotten, that technically I had computed phi y, phi x expectation, and therefore I have to take a dagger of that. So this will be the full computation. E to the power minus beta d3k nk omega k is coming from e to the power minus beta h acting on nk bits. So this is a real number which has come out, and the remaining thing which is surviving inside is phi x phi y operator squeezed between nks, and this is the result for that. And everything was supposed to be z beta divided by z beta. Now this z beta computation we have done so many times, it would have all those nk overlap which will appear in this and that computation as well. So in the numerator again, overlap between nk is coming through as we have discussed, and in the downstairs in z beta also the same thing is appearing. So overlap like before, z beta cancels out all this n omega factors in up and down. What more, we had previously realized that Z beta has exactly this structure, that it has all k is possible 1 over 1 minus e to the power minus beta omega k. And here I have a nk times this summation, or 1 times this summation, or again nk times that summation, both the summations which we have done. So this computation for all other k different than all other k prime different than k again will ride along with nk here and get me the factors which we had seen in the previous class in the expectation of the field operator themselves. So remember, nk e to the power minus beta omega k nk turn out to be e to the power minus beta omega divided by e to the 1 minus e to the power minus beta omega times 1 over 1 minus e to the power minus beta omega, if you recall. This was the structure we had obtained. Now this thing along with the product k, all the possible k's, then this, all the possible k prime over here, then this k value, together they cancel the this kind of factor coming from the z beta. So I will be left with this only as far as this nk kind of summation is concerned. For one kind of summation, it is exactly cancelled again with this j beta factor. So ultimately what I'm saying, the product and the sum here are two kinds, nk times this or just e to the power minus beta nk with 1. So ultimately I'm going to get from nk e to the power minus beta omega k for all k primed, this thing, this is for a single k, and sorry, let me write it more cleanly, that for all k prime not equal to k, I have just e to the power minus beta omega k and k, where nk, sorry, omega k prime and k prime, and for just for a single k I have summation nk, then nk times e to the power minus beta omega k and k. So this product is for all possible k, out of which all but one has this plain exponential character. Only one term has an extra nk, which is appearing over here. This divided by z beta leaves me the Planckian factor 1 over e to the power beta omega minus 1, the expectation n. So this is nothing but expectation of n, this term, this times the partition function divided by this times the exponential divided by the partition function is nothing but expectation value of n, which is 1 over e to the power beta omega minus 1. 1 times this factor divided by z beta is 1, because 1 times this factor itself is z beta, and divided by z beta is 1. So they cancel out. Similarly here, nk times e to the power minus beta omega nk, summation over all the possible k's and product over all possible k's, also z beta, also expectation of n. So this becomes expectation of n in the thermal state. This also becomes expectation in the thermal state, and this becomes z beta divided by z beta, which is 1. So ultimately, you can see the computation which we performed for the expectation value of field, very similar kind of computations arrive in this case as well. And ultimately, this whole computation, this nk gets replaced after the summation through its thermal expectation value. This nk also gets replaced by its thermal value, and 1 becomes 1 at the cost of removal of z beta. Z beta goes into defining the expectation nk, defining expectation of 1. Expectation of 1 remains 1. Expectation of nk becomes the Planckian factor 1 over e to the power beta omega minus 1 over here. So you see, now we have the 2-point correlation function in the thermal state, and it has a very nice structure that I have a e to the power I k x minus y. So remember here we had written a minus sign over here should be, which I erased out again, and a plus sign here. So I can write this as y minus x with a minus sign as a x minus y, and here x minus y with a plus sign should become a plus over here. Okay, so you see this is the structure you have. Oh, sorry, I had written it wrongly. So plus x minus y is coming from here. This was minus. This was y minus x, and this is x minus y. And a minus of this thing was also there. Yes. So minus of I k x minus y this becomes, and this becomes plus iota k dot x minus y. So just fix this errors which I had made, because I had to take a dagger, remember, and that I have written in y minus x and x minus y, one of them will have an extra minus sign. So we will get the structure. So this minus of y minus x, I'm just calling it x minus y. That's all. So this n beta expectation appears and n beta expectation appears here as well. So you see we have the 2-point function in a thermal field completely evaluated in the sense of I know what this function is, I know what this is. In principle, I should do this integration and get done with this, and ultimately it gives me some non-zero survival number. But you see, when I take beta tending to infinity, which is temperature tending to 0, if I take beta tending to infinity, then this exponential factor becomes e to the power infinity. 1 over e to the power infinity is approaches to 0. That means this will vanish, and only thing I will be surviving with will be this e to the power I k x minus y, this d3k upon 2 omega k integral 1 over 2 pi q. So if you recall, this was exactly the vacuum piece. Vacuum 2-point function was exactly this. So if I take infinite beta or 0 temperature, I am left with only the vacuum contribution. So the one standing here is the vacuum part. So I can therefore separate out the vacuum part. I can take this 1 times this into this integration on the left hand side. That will become just the vacuum 2-point function. So now I have a result at hand that the 2-point function of a thermal field minus 2-point function of a thermal field in 2-point function of a field in vacuum is equivalent to first term and the last term, nk with e to the power plus iota kx minus y plus its complex conjugate, and nk factor is common. So you see, unlike the coherent state, it did not separate out into the expectation of phi at x and expectation of phi at y, because those things were identically 0. This is not this quantity. This surviving piece on the right hand side is not that. So it is not like a coherent state. It survives with a definite number which depends on your excitation across different modes put together, and you have a leftover residual thermal correlations at hand. Vacuum correlations and thermal field correlations are different, but still the thermal correlation contains a part which is vacuum, and on top of that there is a non-vacuous thermal kind of fluctuation left over. So this again is an important result which will become handy when we start discussing particles put in thermal environment or thermal field. So therefore, you see, vacuum, coherent, and any other state, we can in principle compute correlation functions in that. And these correlation functions are estimate of how much of quantum fluctuations are there, even if when the field is empty. That means expectation is 0. Not empty, but expectation is 0. So in those cases where field expectation is 0, even then quantum fluctuations will do something to our atomic systems, which in the next class onwards we will start seeing. Or if field expectation is non-zero, like if it is a classical kind of field which is mimicked good enough by a coherent state, then also there are inherent quantum fluctuations coming from the vacuum part. The vacuum part, the fluctuations part in coherent state are exactly similar like vacuum state, because otherwise it is like a classical system. So you see, vacuum, thermal, and coherent all come with certain quantum fluctuations, some with larger, some with smaller, and those quantum fluctuations are supposed to do something to atomic system when they start talking to the electric field or scalar field or spinal field. Okay, so I conclude the discussion on this expectation and correlations for different kind of states. We have done exercises for scalars, but you can see now mathematical structure of even a spinal field or vector field are very similar. Oscillator story is common, only extra indices are there. Apart from k, there should be spin sums or polarization sums, that's all. So more or less everything will go through like before, only thing extra polarization direction or extra spin direction will come about in the game, which you have to be aware of. Otherwise, all these things which we have generally obtained for scalars is supposed to go through for any other free field as well. Okay, so I stop over here, and in the next class onwards, we will try seeing how quantum field starts affecting the statements of atomic systems, which we used to discuss with the perturbation theory previously. Now we will try to see how much of perturbation quantum fluctuations and quantum fields bring about to an atomic system. Okay, so I stop over here.